Hi everyone, welcome back to Life in Technologies YouTube channel, and thank you so much for watching and supporting our content. So this is another episode of our Huawei Lab simulation series, and in this episode we'll be discussing how to configure ISIS overload bit on Huawei routing devices. So we know that ISIS is a link state protocol, which means it will have to exchange the link state information for the connected interfaces or the connected networks between devices, and then the local device will compute the best path and install in the routing table. So when a device is overloaded, it means it's not able to handle any transit traffic. So for example, in this setup, we have R1, R2, R3, R4, and R5. So you realize that we have two exits to go to the loopback on router 5. We can either go via R2 or we can go via R3. So what happens when we have an issue on this device? Of course, when you have a dynamic routing protocol, the traffic will automatically switch to the other device. But remember, when this device is restored, the traffic will also switch back to this device immediately. So one thing that you can do is to set the overload on this device, and you can have multiple parameters that you can set. For example, on startup, you can even wait for the BGP status to be re-established before you can start advertising some prefixes. You can also set it to advertise prefixes with the maximum metric, so it will just help to switch the traffic to the backup path without having any downtime for our traffic. So when you configure it to be overloaded, it will set the overload bit to 1. By default, it will be 0, and by default, the overload is not configured on the router. So you need to configure it yourself. So we have either 0, which means it's not set, and 1, which means it's set. So when you configure the overload, it means yes, now this router will advertise routes to R1 and R4 to all of its neighbors with the overload bit set to 1. So these routers will be able to detect, oh, there is an issue with R2. I don't have to forward my traffic to R2. And then they will forward all the traffic downward to R3. So this is an advanced feature of ISIS, and we'll be demonstrating how you can apply it on your network. So let's log into the devices. This is the topology setup. I've opened the Windows. So as usual, we need to do some configurations. We need to configure the sysname. We need to configure the interface IPs, and then we can also activate ISIS. I will do it reverse. I will configure the ISIS, and then I will now do the interface configuration so that I apply the IP address and also enable ISIS on the interfaces. So one thing I'll do, the first thing I'll do is to configure the sysname. So I'll call this R1. Then I'll configure ISIS 100. We always have to configure the network entity. I'll give it the network entity 0100 dot. I'll give this one to be 001.00, and then I give it IS name of R1. IS level should be level 2. Can display this to see what we have configured. So we have this one in place, so I can go ahead and configure the interfaces. Let me just go back and disable and do terminal monitor. So now I can configure the interfaces. Gig 0/0/0 IP address 20.20.20.0, mask is 31. Just to call the interface, I will enable ISIS, enable 100. This is how you enable ISIS. And then we can configure the second interface, gig 001, IP address 10.0, mask is 31, ISIS enable 100. Display this is the configuration. Display current configuration. So you have configured ISIS up here. We have also configured interface IPs and enable SIS on the interfaces. So we'll go to R2 and do similar configuration and do terminal monitor. System start by configuring the system. This is R2. ISIS 100 network entity will be 49.0.100 00.002.00. IS level will be level 2, and then IS name I'll give it R2. Quit interface gig 0/0/0. IP address will be 20.20.1. mask start 1. ISIS enable 100. Configure the second interface gig 001. IP address 20.20.20.2. mask start 1. ISIS enable 100. And then we go to the third router. So we have other lab simulation that discusses details about configuring interfaces, ISIS, and many other protocols. So if you haven't checked them out on our channel, kindly do check them out. So I will undo terminal monitor. Interface gig 0/0/0. Let's start with the ISIS also to avoid reconfiguring the interface again. So ISIS 100 network entity will set it 49.0.100. This one will be .3.0.0, and then IS level we set it to level 2. IS name will be R3. Display this. We are good to go. We do the interface configuration. Interface gig 00. Its IP address 10.10.10.1. mask is 31. We need to enable ISIS. ISIS enable 100. Quit, and then we configure interface gig 001. ISIS enable 100. IP address 10.10.10.2. mask is 31. Let's configure the system to R3. So that is okay. We do R4. So R4 we have 3 interfaces. Do terminal monitor. Configure the system to R4. ISIS 100 network entity should be 49.0.100.000.004.00. IS level will be level 2. IS name should be R4. Wait. Let's configure the interfaces starting with gig 00. IP address should be 10.10.10.2.3. mask is 31. ISIS enable 100. And then interface gig 0/0/1. IP address should be 30.30.30.0. mask is 31. ISIS enable 100. And then interface gig 0/0/2. IP address 20.20.20.2. This one should be .3. mask 31. ISIS enable 100. Finally, we need to configure R5. On R5, we have the loopback IP that we are using for simulation. So system view, sysname, we configure it to R5. ISIS 100 network entity will be 49.0.0.100. This one will be .5. IS level should be level 2. And then another thing that we need to configure is IS name R5. And then we need to configure the interfaces. So interface loopback 0, IP address 9.9.9.9, should be 32, ISIS enable 100. Finally, we need to configure the interface gig 00 connecting to R4. IP address will be 30.30.30.1. ISIS enable 100. So we have finished configuring ISIS. Let's verify our ISIS status. So on R4 display ISIS peer, you can see that we have 3 peers. We have a peer to R3, R5, and R2. On R1 display ISIS peer, you also have 2 peering to R2 and R3. If you display ISIS LSDB, see that we have these LSDBs. You can see that the overload bit none is set for all these LSPs that we have received from the different routers. So the OL is the overload bit. You can see this one. This is the section for the overload bit, and they have given you the full name here. ATT attached P partition. So our focus is on the overload bit. If I display IP routing table, you can see that we have 9.9.9. The next hop is set to the upper path. So the next hop is pointing the best, and the selected one is 20.20. So to make it, just select that one. We'll configure a cost between R1 and R3. So on R3, because I just want to have one best path, R3 interface gig 0/0/0 ISIS cost, I set it to 50. Then on R1 I'll do the same, interface gig 0/0/1 ISIS cost set to 50. So now when I check the routing table on R1 display IP routing table, you can see that we only have one 9.9.9.9. The next hop is set to 20.20.1, so it's using the upper path. We can try to ping 9.9.9 going through. We can press 9.9. It's also going through via the upper path. So what if we set the overload bit on this router? So on R2, display current configuration ISIS. You can see that we don't have any overload bit configuration, and all the LSPs you've seen that the overload bit is set to 0. Display ISIS LSDB, it's set to 0 for all of them. Now what I'll do is, even on R4, you can also verify the same. Display ISIS LSDB, you also have the overload bit set to 0. So on R2, what I want to do is ISIS 100. Then you can use the question mark, always very handy. You set the overload. I'll just set it not on startup. I'll just set it to be active now. On startup means set the overload bit when the device starts up. You can configure other parameters. For example, wait for BGP to come up. You can wait for another link to come up. All those can be configured. So I'll just set the overload bit. So this one says the ISIS set will be set, yes. And then we go to R1, can run the same command, and now you can see that we are getting one LSP and the overload bit is set to 1. You can see that originally it was set to 0, but now it's set to 1. On R4, let's see. On R4, you can see that we are also getting an overload bit set to 1. So when we check the IP routing table, you can see that now our traffic is flowing via the lower path. The next hop has been set to 10.10.10. So it's not advertising it's advertising overload bit for any transit traffic that is coming from the neighbors. But if you check on this router, if we were to set a loopback IP on this router, interface loopback 0, interface loopback 0, IP address 2.2.2, mask is 32, ISIS enable 100. So we should be able to reach the local IPs. You can see that we have 2.2.2 is advertised to us. We can ping 2.2.2. It's reachable. But 9.9.9 should be going through the lower path. So what happens when we lose this other path? For example, if I were to interface gig 0/0/0 ISIS, no, I need to shut it down. On R1, let's see what we have. Display IP routing table. You see that the routes have reduced. We now don't have a route to 9.9.9 because this router is advertising itself that if you are sending traffic to 9.9.9, don't use me. Don't forward traffic. Don't forward any transit traffics to me. Does it have the route itself? R2, display IP routing table. You can see that it has 9.9. Are we able to reach 9.9? We are able to. So it's able to reach the remote networks, but it's not able to forward any transit traffic that is coming from one device, and it has to traverse its this router, the router that we have set to be overloaded. So you can see that now we have a failure, like we don't have a path. We have a disconnect in the network because this router is advertising the overload bit and this link is down. So we end up having an issue in the network. So whenever you are doing this kind of implementation in the network, you always have to pay attention and ensure that you implement it the best way. Don't just set the overload bit. Use more redefine features, like you can set for the BGP to come up, so when the BGP is not up, it will advertise the overload bit. When a given link is down, it will advertise the overload bit, and many other options that you have instead of just setting it to overload bit. So I hope you've enjoyed this session, and see you in our next episode. Bye.